Hi there, this is Dave from the Cordless Corner. Today I'd like to discuss with you the basics of Arduino digital input and output. The way that Arduino outputs work can be slightly counterintuitive at first, so I've drawn a diagram here on my whiteboard to try and help explain things a little bit better. When an Arduino output is low, it is actually acting as a current source. It's sourcing electrons, so the circuit current flows out of the circuit and towards the higher voltage. So we call that a current source. When the Arduino output is high, it is sinking electrons. We can see here that the electrons from ground flow through the circuit towards the 5 volts. So we've got two identical circuits here, one connected one way around, one connected the other, and electrons flow through them in opposite ways. When we use an Arduino pin for input, the Arduino pin shows up as a very high impedance resistor in parallel with your sensor or switch or whatever else is connected. From what I've read, the input impedance is extremely high. I've never measured it, but it's apparently in the order of high tens of mega ohms towards 100 mega ohms, which essentially means the sensor will see no load from that whatsoever. There's one last mode I'd like to cover quickly, and that's called input pull-up. On pin mode, instead of asking for input, you can ask for input pull-up. What that essentially does, you've got your Arduino pin here, and you've got your 5 volts here. What happens is, input pull-up enables an internal resistor between the input pin and 5 volts. Connecting a switch to an Arduino seems simple enough. What would be wrong with this circuit? Let's have a quick look. We've got our pin here. We just connect a switch to it and put that switch to 5 volts. What might be wrong with that? Well, that's the way we probably all learned to connect a switch in physics, and there'd normally be a light bulb or something here. That doesn't work. That will produce an awful lot of noise on this pin when the switch is open, and it will go between being on and off in state of low or high. What we need to do is we need to introduce a resistor. We need to introduce a resistor into the circuit so that it's stable when the switch is open and it doesn't act like an aerial. We can either connect this resistor to 5 volts and connect this to ground, or we can connect the resistor to ground and this to 5 volts. And whether you do it one way or the other, one way is called pull up. It's pull up if you pull it to 5 volts and you have this set to ground. It's pull down if you have this set to ground and this set to 5 volts. So this is pull down. The other way around, which would just be pin, 5 volts, switch, ground. There we go, that is pull up. So we've got our small diagram here, which looks somewhat like a regular LED that you may have connected to an Arduino before. You can see underneath that here I've got the circuit symbol. That's how the two map, so you can tell the positive leg because it's slightly longer. You can also see the negative side has a little flat area that's quite easy to find. So either of those things will let you determine the positive and the negative leg. So, given that, to connect it to an Arduino we need to know two things: the forward voltage and the current. So in terms of forward voltage, a standard red LED is generally about 2 volts and will need about 20 milliamps to light up to its full brightness. Interestingly, that's about the maximum that you can draw from an Arduino pin without needing to boost the current through an external circuit. And if you need to do that, I have another video that demonstrates that. But moving on, so here we go. We're going to build a circuit. Here's our pin. And we take an LED from the pin. Now we're going to assume that when the pin is high we want the LED to light up, and when the pin is low we want the LED to dim and turn off. So in that case we probably want to connect it this way. So when the voltage is higher the LED will let current flow. The next thing we need is a resistor, because an LED is a very low resistance. Even though it has a voltage drop, the resistance is extremely low. If you just connect an LED directly to ground, you'll damage the LED and possibly the Arduino output as well. And then this goes to ground in this case. So when this is high, the LED is on. When that is low, the LED is off. We can go the other way around and we can draw the circuit this way, and we can connect the circuit to 5 volts here, and when this is low the LED will light. So we can go either way around. It doesn't actually doesn't matter which way you go, either way will work equally well. Now we need to know the value of this resistor. So we know that the forward voltage is 2. That means if we look at it from here on the top one, that means at this point here we'll have about 3 volts. Let's just do a little bit of Ohm's law. We have a bit of space down here on the board. So the current is equal to 3 volts over 220 ohms, and that approximately equals 13.5 milliamps. The reason for that is that's enough to brightly light an LED and not enough to cause any damage to an Arduino pin. Before we proceed, I'd just like to quickly show you the circuit that we're going to build. We can see here we're going to use pin 30 on an Arduino Mega. You can use whatever pin is appropriate for your device. We're going to use a 10 kilo ohm resistor as the pull down resistor, and connect the other side of the switch to 5 volts. So that gives us the setup that you would expect, that when the switch is open it's low, and when the switch is closed it's high. So as you press the switch it will go high. On the other side we're going to invert the logic, and we're going to make it so that the LED is on when pin 31 is low and the LED is off when pin 31 goes high, because both sides will be at 5 volts. So we're going to need a 5mm LED, a 10 kilo ohm resistor, a 220 ohm resistor, a micro switch, and obviously an Arduino board and a bit of wire.